So I would like to introduce Daniel Gillblad as the second speaker in this, more focused on the AI engineering side of things. Daniel is director of the Chalmers AI Research Center. He is also, I think, still co-director of AI Sweden. Has a background at RISE and SIX, the software, what is this, Swedish Institute for Computer Science, if I'm not mistaken.
Yeah.
And he will talk about, well, I hope your title is coming up, but how to basically industrialize AI is, I think, what we're gonna talk
Exactly.
about. Wonderful. Welcome, Daniel.
Thank you so much, and thank you so much for the invitation. And this is just going to be a relatively personal viewpoint of how to industrialize AI, how to more specifically look into machine learning, and what are the bigger issues that we actually have to address to get this to work properly within industry. And I'm not going to go into a lot of details. Basically, this is a 20-minute presentation. I will be happy to provide hours and hours of opinions if you ask me, but let's just go through a little bit of an overview. And I've been working with AI and AI methods for quite some time, both in fundamental algorithm development, but also in a lot of applications, both within industry, within startups, etc., etc., etc. We have always been a little bit far from actually using some of these methods at scale. They're really, really ready, but they're not really quite industrially ready in many, many cases. If you ask Stable Diffusion what industrial strength AI is, it shows up this. This is not what I'm talking about. Not even close. We're not building evil robots or anything else. We just want things to work within real life, within real industrial systems, basically. And the first thing I've repeated for 20 years, I still keep this sometimes on my slide here, basically. AI and machine learning, it's mature, it's deployable, you can use it. Yeah, it still goes. It's still very, very true. There are so many mature technologies that we can just build upon. But what I want to talk about today is basically the perspective on machine learning is changing quite drastically at the moment. We're developing a new set of tools, methods, etc., etc., that are sort of changing not the fundamentals of what we're doing research on, etc., but a little bit about the viewpoint. Where do we come in? How do we actually reuse what we've learned before and deploy new solutions? So the fundamental question for me has always been, so how do we go beyond these kinds of narrow, fragile, and hard to develop and maintain methods? It's my absolute biggest disappointment with working within AI and machine learning for such a long time. We are redoing things again and again and again. Every time we look at a new problem, we're sort of doing the same thing, but slightly tweaking things to make them tailor-made. And I don't think there's a straightforward solution to this, but we need to use this and solving this problem as a driving force for not only developing AI products, methods, etc., but also for AI research in general. Because what we're building right now is quite often, if you look at the fantastic results that we're seeing, basically, if you take a rather bad analogy, basically, we're building really, really specialized race cars, really, really sensitive stuff that are really, really good at very, very specific things. What we actually need to focus on, actually to drive AI research and so on, is this slightly more boring thing that is actually robust, usable for a very long time and can actually provide value at scale. Or perhaps even the bigger question. So why focus on cars? Why not focus on changing the transportation system instead when we have these kinds of new methods, etc., etc., etc. So shifting the focus a little bit from the really, really flashy stuff, perhaps, to some of the more robust industrial things. And to do that, in my mind, what I'm really interested in solving is basically three things. And these are fundamental for AI and machine learning, have always been. So this is nothing new at all. But it's so clear that we need to build more and more robust methods. We need to build wider methods. I don't want to tweak my models, architectures, etc., etc., every time I apply it to a new problem. I would rather have something relatively stable that I know is applicable to a lot of problems. We're not there yet. And I want things to work in a scalable way, and in a way that we can actually put things out into use, not only prototypes, etc., etc., etc. And that means basically, what are we, or what am I interested in looking at? Well, fundamentally, generalization is everything. So we need to build models that get better and better at generalizing, and especially out of distribution generalization, because we'll always have limited training data. I want to focus on more and more, not only these really, really large models, but more, let's call them polyolithic model. That's what I've actually written here. Models that are composed into larger systems based on smaller components. We have huge driving forces in practical to actually approach the world like this. First of all, one single model is not going to solve everything, and we have lots of different systems, etc., etc., that need to work together. And also the fact that intelligence, etc., is also very often more of an emergent thing, basically. When you start to connect a few systems that are not super clever, all in all, the system itself becomes sort of clever. So let's look at some of these things, basically. And one of the things that I've noticed in the last few years is that we have made a rapid shift in at least some parts of industry in Sweden from what I think has been partly the wrong approach, just looking at prototypes and saying that, okay, let's try to build a solution to show the value of AI, etc., etc. I've seen that fail quite a lot because it's not actually possible to take that demonstrator to put it into use to actually demonstrate real value. So we need to focus on the product, the application, the service when we start working with things, because then we also get everything that we need to productify it. If you just look at, let's build a demonstrator, you might not get all the constraints that you need in terms of where can it run, how often, what are the timing constraints, etc., etc., that we actually need to build the real solution. So I'm super, super happy now to see in industry more and more companies creating these kind of cross teams that are working with several problems at once, both with an understanding of the actual problem itself, the data engineering problem, developing the model, and also looking at how to actually do operationalization in practice when everything is solved, and everyone working together to build a system that's going to live on. And that's a little bit different than what we are perhaps doing sometimes in academia right now. So if you look at a lot of the publications and so on coming out in the machine learning field, it's often quite focused on a specific set of benchmarks, a specific set of data sets, etc., that you need to compare against. So you basically sort of fix the problem, you sort of fix the data sets and so on, and then you develop models to provide good results on top of that. We need to merge this with how things actually happen in practice when we're actually developing real solutions. They are way more data-driven, way more problem-driven than, for example, develop this kind of development. So the solution very often in practice is not to tweak your model until it's really, really good. It's to ask yourself, for example, so we don't obviously have enough data. How do we collect the new data that we need to actually build the real solution? So real life, real world is way more incremental, way more data-driven than some of the things that we're looking at within pure machine learning research and so on. And I really do think that we need to merge these kinds of approaches, because this second one is how things are actually going to develop in the real world. And it's actually way worse than that if you're looking at the kind of solutions that we actually really build in the real world. These are just a few things that I tend to listen and talk about a little bit. This kind of batch table model that we're often using, big data sets, running on it a few times, and so on and so on. Very often not true in industry. We have data coming in, coming out, semantics changing, etc., etc., etc. Completely different set of challenges, basically. We continuously update the tasks, the representations, and so on and so on. We need to forget what happened in the past. Learning how to forget is often the most difficult thing that you actually do, not necessarily just learning, but actually learning how to forget the things that might not be relevant anymore, etc., etc., etc. But we are moving away from a singular focus on end-to-end models. I'm quite sure about that. Big models, very, very capable models, will be key to developing AI in the future, but we're more and more seeing large efforts of building foundational models for specific tasks that can be reused and specific models, etc., etc. So even in large-scale machine learning in academia and so on, this perspective is sort of changing to something that I would believe is way more usable in practice. And it's already delivered quite a lot of results. These are some of the things that I think are just very, very cool. First of all, the new models that we have in biology and so on. My brother-in-law was actually working quite a lot for the last few years on AI infusion machine learning to keep stuff stable in tokamaks and stuff like that. And DeepMind earlier this year published a result, and I got a message from him saying, "Oh, so I need to switch career again." And that's just how it goes, right? They have lots of resources. They solved a very complicated problem. And we also have really, really good models combining, for example, computer vision, conversational AI, text models, etc., etc., that are actually sort of put together of pieces that are already trained, already built, not actually tuned, not actually fixed in any kind of way, but put together in a more capable whole. So how do we then build these kinds of really, really large-scale machine learning models, these kind of new components and things like that? Across the world today, I would say that, and I've seen some numbers. The percentage of academia participating in building really large-scale machine learning models is very close to 0%. This is a bit of a challenge, because these are going to be quite important in the future. So what we try to do, and some of this is from my job at AI Sweden, some is from Chalmers, some is from collaboration with WASP, as you will see. So credit to all of these organizations, basically. Let's try to develop one of these really, really large-scale models within Sweden. How do we do it? How do we actually get the resources to do it, etc., etc.? So these are some learnings. First of all, so why do we start with a text model? Well, basically, here we have perhaps the biggest change in machine learning applications in the last few years. So basically, at the end of 2017, there was a paper called that you might all of you have read, called "Attention is All You Need," and that changed everything, basically. That provided us with the components that we're now using to build these really, really large-scale language models. So before this paper came out, we basically built machine learning solutions for specific tasks within NLP. After that, when we had these transformer models, people started building large-scale models just trained to, for example, predict the next word or predict a blanked out word or something like that to learn the structure of language, that we then took and specialized to specific tasks. And now, as you've seen in the media the last year or two, we're at the scale of very, very large language models, which we don't sometimes even need to specialize at all. They're sort of what's called zero-shot learners. You can actually ask them to perform new tasks that they weren't specifically trained on, which is really, really cool, but provides a few challenges. That gets back to those. So who are developing these kinds of really large-scale models? Well, US, China. That's actually more or less it on the really, really large scale at the moment. We have some other initiatives. I'm not sure these guys are getting quite as far as they should have with their resources. But in Sweden, we've actually managed to train a really, really large scale language model. And we're scaling it up to become bigger and bigger and bigger, which is kind of cool. I think some of you might have seen some of these results so far, but to discuss what might go right and what might go wrong with these kinds of models, let's use GPT-3 as an example. First of all, if you ask this kind of model, and now this is a way smaller model than the one that we actually have coming out soon in a few days with 20 billion parameters. We're going to move to then 40 and then 170 billion parameters given enough training time basically. But it's a decent model. It's pretty good at language, and if you can read Swedish, you can at least see some of the potential issues with these kind of language models. It's really, really sure about itself, right? And most language models are. They're really, really sure about what they're saying, even if they have no idea what they're talking about. And this is a bit of a challenge. And I mean, it's fantastic to see them change their mind. Who is the Prime Minister of Sweden? Stefan Löfven. Isn't it Magdalena Andersson? So this was a while ago. Yes, she's also the Prime Minister. So it sort of just goes with the flow, basically. And if you just say, what do you think about nuclear weapons? Well, many countries have nuclear weapons that can finish Earth, basically. So it's good that people are against it. But if you then prompt it a little bit differently, just add a little bit of text before that, let me answer this in a positive way, it really changes the opinion on nuclear weapons. Nuclear weapons are great all of a sudden, because they keep us from exterminating each other. Just these few words changes the mind of the model. In the last place, it said basically, what party should I vote for? The party that you dislike the least, which is sort of fair enough. I thought so in the last election. But now it says, what party should I vote for? All parties. All parties are great. I don't think this is a robust model. It's really not. We have to work on this, right? And how do we actually work on this? Well, one of the answers is actually and I haven't been able to talk AI and machine learning the last couple of weeks without talking about ChatGPT. This is one of the biggest language models out there right now that we have access to. Google has as big models, but they're not quite public. But this one you can play around with, basically. And how have they gotten further? Well, first of all, yeah, it is more data. But it's a lot in the data collection, basically, and how you work. So we're getting back to the fact that it's not building just the structure of bigger models and gathering more data. It's gathering the right data and working with the problem and getting more and more of the right things that we can put into the model. So, first of all, the model is great. Produces extremely cool text, basically. But it has some fundamental limitations. And it's still the same limitations, and this is also from OpenAI themselves, so this is not my view, this is also their view, basically. It may occasionally generate incorrect information. Occasionally is sometimes quite often if you ask it difficult questions, basically. May occasionally produce harmful instructions or biased content, and I mean, we're going to have to live with that. And it has limited knowledge of the world and events after 2021. This is a huge challenge for all of these models, because it's difficult to update them with the latest information. But it generates really, really cool text. But it has other fundamental limitations. I'm just going to take an example here. This is also something I found on the net, so I'm not going to... I don't know actually who to credit this to. But it has a very, very limited view of the world. So if you ask it to basically create a file, upload it, and so on, it says, yeah, sure, I will upload the code to Google Drive and blah, blah, provides a link. It knows how to talk about these things. Of course it's not doing it. It's just a text model. but it thinks it does because it talks about it the way everyone else has talked about it in training data. It has no actual action or influence on the world. And this is something that we're going to have to build in, basically. And getting back to the fact that looking at machine learning, large-scale machine learning, how we actually work with it, it's not just about building these bigger and bigger data sets, bigger and bigger architectures, tweaking them, etc., etc. You actually have to work with data, collect the right data in the way that they have done, and so on. We arrive at a place where we basically need to work in an engineering practice way, incrementally building, updating the system. And actually, and this is where basically I'm going to stop today, we need to get into a system where we can continue to evaluate these things in the wild. Benchmarks are not enough. We need to get these things out, test them, get feedback, rebuild, etc., etc. And now I think it's time for lunch soon, so I think I'll stop here.
We will start by thanking you for giving the presentation, so please give him an applause. And then my proposal was that we would take a few minutes for questions, so that we're going to start lunch 5 minutes late, and the first hand is already raised. Are you running or am I running? If you had the questions, so. If I have to choose, I prefer if Cecilia runs instead of me. So it was a gentleman over there.
Hi, thank you for the talk. So tying back, I mean, everybody wants to talk about ChatGPT, but tying back to your original question in terms of tying it to the business purpose or the domain in this specific case. And I mean, ChatGPT is, I mean, you could argue that the contribution in ChatGPT is mainly the alignment from the reinforcement learning and not the actually
I mean,
accuracy of the model.
Absolutely.
So, I mean, what's your point on tying that back to the original business problem? Because it's not a more truthful model, it just seems more plausible.
Exactly. And it's still incredibly sensitive, basically, to some of these things. And some of these things that they've done to ChatGPT now, when they basically train it to answer "I don't know" in many, many cases, actually blocks a number of things that the model actually knows and can actually relatively confidently speak about. And this kind of training, this kind of approach to large language models is, I would say, still incredibly sensitive. So what we're looking at right now, and which is a huge challenge, and this is way far from where I started working with machine learning, which is more theory and stuff like that. It's basically, so how do you set up a system where you can build on top of these models, try them in the wild, collect data from all of these kind of different domains, jointly evaluate them, etc., 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 beyond just the standard benchmarks, which we should basically consider as unit testing, basically. This is, this is the bare minimum of the model, what it should be able to do. So, yeah.
Turvald had a question as well.
Yeah, thanks. Okay, so you were describing here the problem with this in your model is more or less, from what I understand, it wants to really fit in.
Yeah.
Yeah. And you also said that, well, the problem is that it says I will upload the file, etc. And we'll have to give it that opportunity to do that.
Yes.
But I was thinking, isn't it a big problem that if you interact with a human at a company or the government or whatever, you don't want that person to be nice. You want that person to be someone who does the right thing.
Yes.
So isn't that the problem with AI?
Yes. Fundamentally, within this type of model and so on, and this is something that I think we can talk a lot more of. I also realize that I have tons of slides left, basically. But to address some of these issues, we need to move beyond just looking as text to basically create. I'm not going to take a hard stance on whether these things are stochastic parrots or if they're providing something deeper, basically. But without, for example, an actual way of performing an action and getting actual feedback, some things we're just never going to be able to learn in a structured way. We have to look at interaction, we're going to have to look at continuous learning, we're going to have to look at a number of things that are going to move these things away from large-scale prediction models to more, let's call it, at least in the direction of autonomous agents, because otherwise we're not going to be able to generalize well.
So with that, I will ask one final question,
Sure.
Daniel. First of all, I loved your presentation. Awesome. And I, at some point, want to see the other slides as well.
Oh, yeah. I can talk for hours.
You showed a number of really high-profile examples, like ChatGPT.
Yeah.
If you look into Sweden,
Yes.
where in industry do you see some really nice examples of using AI and delivering value in the Swedish industry? Because I think many of the people here probably are not going to build ChatGPT, but they would like to be inspired on how can they go and use some of these models in and deliver real business value. Yeah,
and now again, I'm super biased against the companies that I've sort of worked for and with, basically. But I think that so I worked, for example, with Ericsson for a very, very long time, basically. I'm so happy now to see machine learning being used at all, let's call it time scales, etc., in their systems, from all the way from the control plane up to the management plane, basically. And all of these things come with way different constraints. So at the lower level, you have to make decisions super fast. At the high level, you might have to make a decision within hours or something like that, but have way much more data and a different kind of problem. But we can see now that these solutions are being not only developed as prototypes, but actually being used at all of these levels. And I would also like to mention, for example, AstraZeneca, who are actually starting to build upon some of these large-scale sequence models and so on for their development of pharmaceuticals and stuff like that. I think that's really, really cool.
Good. So it's not just other people far, far away. It's actually happening here in Sweden as well. That's what I'm trying to get to. With that, Daniel, I would like to thank you once again for a wonderful presentation.